Once again, welcome back to the Reliability Matters podcast. My guest on this segment is Dalton Dodge. He's with Brooks Automation. Welcome, Dalton. Thanks for being here.
Thank you very much. Thank you for having me.
We are going to talk. I found out about you about 86 seconds ago, and so I don't know much about the products you make, but from what you told me in the last 86 seconds, it sounds very interesting. You make robots for automated test islands. Okay, let's back up a little bit. Robot part I can get, and we'll get into that. Tell me what automated test islands are, what type of application within the electronic assembly space, testing obviously, that are they used for, and then let's get into how your robots integrate within that space.
Sounds great. Yeah, so we have been selling collaborative robots or innovating collaborative robots for many, many years. We are an industry leader in laboratory automation, and in that industry, the application is very much similar to what you'll see at the digital test booth, which is we are accessing high-density storage racks of samples, in this case panels or PCBs, and the robot is sitting there all day long accessing those, loading and unloading automated FCT, ICT, burn-in, you name it. This would be a back-end application after the entire SMT process. And what we're really trying to focus on and showcase is flexible automation that's affordable and doesn't require end users to really have to develop a very expensive, crazy production line. It should be very accessible, and they should be able to adapt their existing production lines to something like a collaborative robot.
So these tests, you mentioned ICT, I think you said FCT, these types of tests, are they historically performed just by human hands, and you're not changing the test protocol, you're making it more efficient?
That's right. In parts like North America, Europe, of course, this has been done in Asia heavily. I think COVID-19 exposed the supply chain very much, and now you have companies wanting to future-proof. You have a lot of companies looking at wanting to do lights-out manufacturing, 3 shifts a day. Labor rates are going up, I think, universally everywhere, and now people are really looking at automation more than ever. If you don't have the capital to justify a very, very expensive inline system, I think the gap fill, and we believe the gap fill could be something like a collaborative robot, which is, again, very flexible, much more affordable. People, I think, understand robots to a degree, especially when they're easy to use.
More now than ever, yeah.
Now than ever. The education's out there. And take a typical production floor, you're going to have 2 to 3 shifts, many banks of testers. Someone is ultimately paying someone to sit there, load and unload these testers all day long. While that's great, completely understand, there's a lot of room for human error. Quality might suffer at some point, especially when you have guys working longer than 8-hour days all the time. And so the robot serves as that step in to perform that task. So
on the subject of reducing human error, I can understand the labor component.
Sure.
Yeah, we take a person out of it. Obviously, it's going to be a little cheaper once some ROI on the investment. From a reliability standpoint or a consistency standpoint, what types of errors do humans make typically? I know it varies on the type of testing, but in general, do humans make that robots tend not to make?
Sure. One off the top of my head could be, someone could be very tired or working extended hours. You're using your eyes to do very basic, say, part presence, part absence type of inspections, nothing super heavy. But there's room for error there. Someone could mistakenly put a pass board into a failed magazine, or more importantly, a failed board or a failed assembly into a pass batch. Down the line, someone's going to encounter that. There will be a bottleneck somewhere, that can cascade anywhere on the line. Those are just two basic examples, of course.
So if I said, okay, Dalton, I'm sold. I'm going to buy a system, integrate it with my testers. Do I integrate it with my testers? Do I tell you? Does Dalton say to me, okay, tell me what kind of testers you have, what type of parts you're testing, tell me more about your environment, we'll pre-program everything. Does it already come out of a box knowing who it's playing with?
Sure, yeah, there's a little bit of a story to tell there. So Brooks, we are focused on innovating the robots and manufacturing the robots. And the way we try to get our robots onto production floors and help people out, we want to identify very competent systems integrators or value-add distributors. From the robot's perspective, it's agnostic to tester A, tester B, software A, software B. We look for people that understand robots, understand test excellency, understand the customer, they see the robot as a value add, and they're going to tie the robot into an existing line, make it communicate to the tester, package all that together mechanically, and deploy that into a work cell. So from the robot, doesn't care if it's tester from vendor A or vendor B. It just wants to sit there literally all day and load and unload the tester.
Interesting. And finally, last question. If I was in the market to buy something like this, and I didn't know much about you, I don't have to actually go too far off the reservation to know that's true, because I don't know much about Brooks Automation, but I don't know much about the whole industry. What types of questions should I be asking to be an intelligent discerner of the different options that are out there for automating tests? Procedures?
I think a very common one actually, and this people might not even really think about this because it's just out there all the time, but there's angle testers versus flat testers. Some robot manufacturers will only offer a variant that can do 6 axes, some have 4 axes. So literally how the test cell is set up mechanically is something to consider. With collaborative robots, more importantly, people would need to understand that there will always be not a fight, but you have to think about throughput versus accuracy versus flexibility versus reliability. If you want things to rip and really go fast and maintain throughput, a robot could probably do the job, but you'd also probably consider an inline system. And then, the faster the robot goes, typically the more unsafe it is. And if it's really an unsafe system, now you get into caging the system and really blocking off your operators from accessing it. It's not really collaborative. It's not flexible. So safety should be probably
there's a happy medium somewhere.
That's right.
Right.
Yeah.
And your company could help guide. I'm assuming it's probably important for the customer to ask the right questions, but it's equally important, maybe even more, for you to ask the right questions. Right.
My background is in applications, and I believe applications engineers should be masters of asking those type of questions to the customers, helping the customer define their specs so that they're very well informed and understand what they're getting at the end of the day.
Excellent. Yeah. Well, Dalton, thank you so much for being my guest today. Thanks for spending the last few minutes educating me. I feel a little bit smarter today. So, if I happen to fall into a conversation about automation of test systems, I can at least carry a 5-minute conversation. So thank you very much.
Thank you for having me.
I appreciate you being here.
Thank you.
All right. Have a great
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.